So day 2 of piecewise functions. Yesterday we were given a graph and we wrote the piecewise function. Today we're going to have the piecewise function given to us and we're going to graph it. So what we're going to do is we're going to graph each of the 3 pieces and then only highlight what piece of the domain that we need. So let's get started. I call this, we're going to graph and erase. That's our strategy for today. So the first is a line. I'm going to graph it with a pencil. Looking at the y-intercept is 3. It's a slope of 1, up 1 over 1, up 1 over 1. Now we're going to draw the line. I'm going to draw a dotted line because I don't need all of this line. Now I look at the domain. X is less than or equal to -3. So I go to x is -3 and it's equal, so I color in the point of the graph there. And x is all less than -3, so I color in the rest of the graph. And that's the piece I need. The next graph, y equals 4. Well, that's a horizontal line. Y equals +4. So I'm going to draw it with my dotted line for pencil. And I'm going to look at the domain. I'm doing a different color. My domain is from -3 to 0, not including either one of those points. So I go to -3 and I draw an open circle. I go to x is 0, I draw an open circle. And then I trace in between. And that's the piece I need. Okay, and then the last one is a line with a y-intercept at -4. It's a positive slope, up 2 over 3, down 2 over 3. So here's my line. Dotting it in with pencil, and then I'm going to color in only the portion of the graph that I need. So x is 0. I go to the graph, it's equal, greater than or equal to 0, so I color in that point, and then I trace the rest of the line. There we go. Now, what I can do, at this point, is I can just take an eraser, so graph and erase, that's what I meant, and just erase all the pieces of the graph that I didn't need. And there you have a piecewise function. If you're only using pencil, then you need to erase. If you're using a marker and a pencil, I'm okay if you don't erase. So I can clearly see that you understand the piecewise function. Okay, next one. A little bit harder because we have a quadratic. So what we do is we're going to have to plot some points. So we've got our quadratic. Y equals x squared minus 2. Well, I know the vertex. The vertex is hk, 0, -2. All right, so I can go plot that. 0, -2. This is going to be the vertex. Well, I need a few points, so I make a little table. I know the vertex is 0, -2. I'm going to graph 2 points to the right of the vertex. And then I'm going to reflect them over the axis of symmetry, which is at the vertex, x equals 0. Okay, that's what I'm going to do. So let's plot these points. When x is 1, so you put in 1 squared is 1 minus 2, -1. 2. 2 squared, 4 minus 2 is 2. Now I just plot these few points. I've got the vertex 1, -1, and then 2, +2. And you see I'm going to dotted line because I don't want all of this graph. There's my half of my quadratic, and what I'm going to do is I'm going to take these points and I'm going to reflect them over the axis of symmetry. This is the axis of symmetry, so I'm going to reflect it. And then I'm going to pencil in my quadratic. So I've graphed, and now I'm going to find the domain that I need and then erase the rest. I need x less than or equal to 2. So x is 2, it's equal to 2, so I circle it in, and then I just trace everything where x is less than or equal to 2. Okay. The next piece of my graph is a line with a negative slope, so I just think about that. That's how I want the slope to the graph to look. And I say, okay, I'm a y-intercept of 5, and it's rise over run, so 1 over 2, down 1 over 2, down 1 over 2. Do I have the slope right? Yes, that is -1/2 slope. So I draw my line, and I look at the domain. X is greater than 2. So I go to X is 2. I go up to my graph. It doesn't exist at 2, but it exists everywhere greater, where X is greater. Now I have a piecewise function. And if I wish, I can erase the pencil that I had, and there you have it. Okay? All right, let's do one more. Flip over your page. Okay. Now, we have a quadratic and a line, a horizontal line, and a root function. So we're going to have to graph these three and get the pieces we want. So the quadratic. I have y equals x plus 4 squared minus 2. My vertex is x minus h, negative 4, k, negative 2. Let's graph that piece. X is negative 4, y is negative 2. And then I'm going to make my table, right? So I make a table. X, y. The first point I put in is the vertex, negative 4, negative 2. And then I go 2 points to the right, negative 3, negative 2. And I plug these in. And just do it. You don't have to do it in your calculator. You could. Negative 3 squared is 9. Excuse me. Negative 3, sorry, let's do the parentheses first. I plug in negative 3. Negative 3 plus 4 is 1. 1 squared is 1. 1 minus 2 is negative 1. Now I put in the negative 2. Negative 2 plus 4 is negative 2. Negative 2 squared is 4. 4 minus 2 is 2. Let's plot those points. I have x is negative 3, y is negative 1. X is negative 2, y is positive 2. And I pencil in my first half of my quadratic. I know the axis of symmetry is right here at x equals negative 4 at the vertex, so I reflect over the vertex. This point reflects here, this point reflects here, and now I'm ready to draw in my quadratic function, all of it. Okay, so that's my quadratic function. I'm going to pencil it in so you can see it more clearly. But I don't need all of it. What do I need? X is less than or equal to negative 3. So go to x is negative 3. We want everything less than. We color in this point because it is equal to, and then we trace the left, everything left. There we go. And then I can, if I wish, erase the rest of that graph. Okay, next one is a line, y equals negative 5. Well, that's easy. It's just a horizontal line at y equals negative 5. So I draw that dotted line. Then I look at the domain. X exists, this function exists from negative 3 to 1. Okay, so x is negative 3. Go down. Now I color, I put an open circle because x is greater than negative 3 but not equal to it. And then at 1, I do color it in because it's less than or equal to. So this is that piece of that graph. One more, a root function. Well, how would I do this? Well, first I would identify with the root function what are h and k. X minus 1. K is 2. So this graph is going to take the parent and shift it right 1 up 2. So what I would do is I would draw the parent. The parent is 0, 0, 1, 1, 4, 2. And we just know this from doing root functions. There's my parent. Now I'm going to shift it. I'm going to take each point and shift it right 1, up 2. Take this point, right 1, up 2. Take your fourth point, right 1, up 2. I have now, again, shifted my graph. You can draw this in if you like, in pencil. Okay, I don't need all of it. What do I need? Look at the domain. X is greater than 1, but not equal to 1. So I go to x is 1. I need almost all of it. I draw an open circle at x equals 1, and then I pencil in the rest of my graph. And I can erase the original, and there I have a piecewise function. Okay? Now, you can go ahead and try this one. It is all things you've done before: a line with a negative slope, a quadratic function, and a horizontal line. We're not going to do that. You can do that on your own and check in with me next class to see how you did. Okay.